Hey students, it's Mr. Irvine, and this is the first video lecture for our flipped classroom. And so watch this video, and then at the bottom of the screen underneath the video is some summary questions that you should answer and submit to me after watching the video. And remember, you can pause, rewind this, go back. And so we're going to start off with the nature of science, what science is, how it's done, the scientific method, all of that. And so let's begin at the beginning, the word science, which comes from the word scientia, which is right here, which is Latin for knowledge. And so it is a great definition. Ooh, gotta work on my handwriting here. Knowledge, and that's what it's all about. I mean, that's what science is. It's finding out the knowledge, the understanding, the information about our natural world, the world around us. Now, as for a definition, there are, if you ask 10 different scientists a definition of science, you're going to probably get 10 different answers. And that's because there shouldn't be a specific word-for-word definition of science. But basically, it is an understanding and an acquisition of how the world works around us and through gathering data. And so anyway, let's get into this here. You gotta be kidding me. Alright, hey students, it's Mr. Irvine, and this is the first video lecture for our flipped classroom this year. And so watch this video, jot down some notes if you'd like, but mostly what I'm looking for is down below this video are some questions to answer, and make sure you click submit and submit those to me. That's where you'll get the points.
Joe, please call extension 400. Joe, please call extension 400.
I can edit that out. So this first one is the nature of science, how science is done, scientific method, how we acquire the knowledge of science. It's a great place to start, and I think an important one. So let's start from the beginning, the word science. The word science comes from a Latin word, scientia or scientia, which is the Latin for knowledge. And so a great place to start just with the word knowledge. And I'm getting used to these pen tools, so stick with me here. Yeah, Latin for knowledge. And that's really what science is. Science is gaining knowledge, and sometimes that's through observation, sometimes that's through experimentation. And so there's several ways we can get at this knowledge or this truth, and there's many different ways of getting to it. So as far as definition of science, I don't like a word-for-word definition. Not many people do like a word-for-word definition, because you can ask 10 scientists what science is, and you might get 10 different answers, at least the definition. But to come to an understanding of what the nature of science is what I'm looking for. All right, so we will now look at what science is. And science is kind of interesting because it's really two different things. It's both a verb and a noun. And what does that mean? Well, let me explain it. So to do science is sometimes a process, and sometimes it's a verb. And so the scientific method, or going through experiments, going through that process of gaining the knowledge, is science. But it's also a noun. Science is an accumulation of knowledge and facts and data, and analyzed data and truths and theories and laws and hypotheses. So it's a kind of a volume of information. And so it's kind of neat that science can be both a verb and a noun. And so one of those, here at the bottom, this process, if you will, the scientific process, a lot of people will call it the scientific method. And so the scientific method, for example, starts off with an observation and then runs through different formats to get to the end result in knowledge. Let's say you are a rock climber. I like to climb. And you are climbing the rocks, and you notice that your climbing chalk right here falls down onto these plants. And that's an observation. And so you want to know, what is the effect of your chalk on those plants. You want to know if you're harming them, if you're benefiting them, or if there's no real effect. And so you've just started the scientific method. You've just started science by seeing an observation and asking a question, and you want to go further with that to complete the science. And so before we go through the scientific method, a little bit of history of science. Start out with this guy, Aristotle. He was, back in the day, a philosopher, but also he was really one of the first ones to try to look at what's going on in nature and the world around him and try to see what the reasoning was. So this photo right here, or this painting rather, by an artist named Raphael, is a great depiction of this. So you can see this is Aristotle right here, and his fellow philosopher Plato is pointing up towards the sky, and so he was very into the thought process, the philosophy of what is going on in the world around them. But right here you can see that Aristotle is kind of motioning towards the ground. And so this is a representation of his, there's arrows everywhere here. There's a representation of the world right here, not the thought, not the philosophical part, but right here down on earth. And so that's I love the painting right here Raphael does of him showing that we need to think about here. We need to look at the fire, wind, earth, air, all those elements and forms is what he called it. And so he was really one of the ones that started off the thought that, here's a good quote here, knowledge through empirical observation and experience. So observation, numbers, data, experiencing it, so to gain that knowledge that way instead of just thinking about it, philosophizing about it. And next, a little further down the road, Galileo. You may have heard of him and think of him as space, and yes, he had a lot of experiences and discoveries about space. But he also was one of the first ones to really take ideas and experiment with them. And so taking that scientific method from not just questions and observations, but then putting them through experiments. And one of those you may have heard of had to do with a tower in Italy. He's an Italian that was leaning just a little bit. And so the Leaning Tower of Pisa. And the story goes, I'm sure it's probably true, but the story goes that he wanted to see, he thought that if you drop balls of different sizes, different weights from the top of the tower, that he wanted to see what they would do. If the heavier ball would fall faster than the smaller one. And so he did that experiment, and lo and behold, he found, looking for the erase tool here, can't find it, but he found that to the observers below, when he dropped those two balls of different size, they landed at the same time. And so he came up with his thoughts and ideas, hypotheses on gravitational pull on objects of different sizes. And so his stuff really kind of led the way again to experimentation through science. All right, back to the scientific method. Oh, and Einstein, by the way, called Galileo the father of modern science. So pretty big deal. So when we're running through the scientific method, although there are several ways to get to truths and get the data, you want to follow this scientific method plan here. So first off is the observation. An observation is through the five senses: sight, touch, smell, hearing, and taste. And the sixth sense, seeing dead people. But the five senses will allow you to observe things. You don't always have to observe them with your eyes. You can observe them with smell, like smoke coming from a fire, or taste when you put something in your mouth, like bad milk. Like that's a pretty big observation. So let's go back to the rock climbing observation. So rock climber wants to know, what is the effect of the chalk that they use on their hands on the plants? And so that observation is that my chalk is falling on these plants and falling on the soil of these plants. And so you've got your observation there. Now your question. And so your question in this case might be, is there a negative effect of climbing chalk on plant growth? Okay, that's a pretty good question, and one that's testable. And so your question in science has to be testable. If it's not testable, it's not going to go anywhere. You're not going to get any truth from that. So then you'll come up with your hypothesis, and a lot of you have heard educated guess. That's what a hypothesis is, and so that's good. So it's an educated guess what you think is going to happen. In this case, I feel that the climbing chalk is going to negatively affect the growth of plants. All right, that's my hypothesis. That's my thought. You can't just stop there and say that and be like, I'm done with science. No, you haven't gotten to any truth yet. You haven't gotten to any knowledge. You've just come up with what you think is going to happen. And so in this case, you need to set up an experiment. And so let's set up an experiment. Let's say you have a plant. All right. And here's your plant. And you want to know whether or not the chalk has a negative effect on the plant growth. And so you're going to set up an experiment. You're going to have a plant, and you're going to add chalk to that plant. If you add chalk, let's have our chalk here, to that plant, and then it dies, is it the chalk that killed that plant? Well, you don't know. You don't know if that's the case. It could have been a disease in the pot. It could have been just a bad plant. It didn't have to necessarily be that chalk that killed that plant. And so you need to do more than just one plant and one chalk. And so let me get rid of this here. And so your experiment needs to have multiple groups in it. And so let's say now you have one plant here, another plant, and a third plant. Oh, let's put some petals on those flowers, and please excuse my drawings here. They are from a mouse. I need to get my pen handy. And so you've got these 3 plants here, and you're going to add different amounts of chalk to each of them. So let's look at the variables. We need to define the variables before we begin our experiment. So we've got this set up, we've got the plants. So what are the variables? The variables, there are 3 of them. So, and here's, the climbing chalk and the plants. So you want to look at the effect, what effect the climbing chalk has on plant growth. Your variables here, you've got the independent variables, dependent variables, and then your constant, or some people call them your controlled variables. Your independent variable, this is how I remember what your independent variable is. It starts with the letter I, and so your independent variable is what I change in the experiment. All right, and so what the experimenter changes, that's the independent variable. In the case of the plants, the independent variable is going to be the amount of chalk in the plant soil. Say we're adding it to that. And so for this case, independent variable is what I change. And let's say I do 5 grams of chalk in this one, and let's say I do 10 grams of chalk in the other one. And so that variable is the amount of chalk in the plant. It's what I changed. The dependent variable, on the other hand, it's dependent on what happens for the independent variable. So for dependent variable, what I say is the dependent variable is what you measure. And so in your experiment, you're always going to be measuring something. And that doesn't mean it has to be a ruler. There's lots of different measurements. And so whatever you're measuring, in this case, I define my question as what effect does climbing chalk have on the growth of the plant? So in this case, I would need to define my measurement, my dependent variable. Is it the length of the plant? Is it the number of leaves of the plant? Is it the coloration of the plant? So you need to define what your dependent variable is. But your independent variable, what I change, dependent variable is what you measure. And your constants. If you add 5 grams of chalk here and 10 grams of chalk here, and this plant here gets an hour of sunlight a day, and this one gets 6 hours of sunlight a day, and this one dies, is it because of the chalk that it died? Well, you don't know, because it could have been because of the amount of sunshine. So it didn't have enough photosynthesis to create enough energy to live. And so that's one of your constants. So one of your constants could be, sunlight exposure. You want to make sure you keep all these constant. That's why they're called constants, because you keep them all the same for all of your experimental pieces here. So it could be sun exposure, it could be water, amounts of water, it could be amount of soil, it could be lots of different things that you need to keep constant. You basically need to keep everything constant except for your independent variable. That's the one thing that you change. Everything else, if you can help it, is exactly the same. All right. So those are your constants or controlled variables. Other than the variables, you also need a control group. And the control group would be in this case the plant that you do nothing to, you don't do anything different to it. You keep the same water, keep the same sun exposure, but you don't add any, you add 0 grams of chalk. And so what I call this group is the group under normal conditions. All right, and that's very important. You need a control group to compare the other groups to, because again, you don't know if it's the chalk that's having an effect unless you can compare it to normal conditions. And so this plant here, and it would be best if you had a couple control plants, but sometimes money isn't always available for that. Your control group, if it lives and your ones that you're adding chalk to die, you have a better case that it's the chalk that's doing the damage, because your control group that had no chalk was not affected. And so you got to have a control group in any controlled experiment. Then you want to collect your data. So your data is usually, well, pretty much always kept in a table. And so as you collect that data, you're collecting it in a table. And then once you have that data, you then want to show it visually. And so that's where graphs come in handy. Graphs are a wonderful way to show your data. Sometimes just data tables, you get dizzy looking at all those numbers. And so you want to express that in a nice visual sense. We in science don't make students do graphs just to torture you. It's very, very important to show your audience your data visually. And so in this case, for plant growth, you might have a bar graph. That would probably be the best way for each plant to show the growth when you're doing independent pieces. If you are doing an experiment that shows a change over time, or maybe rate of growth, then you would want a line graph to show an increase or decrease or staying the same over a certain amount of time. When you're doing your data on a graph, you always want your independent variable to be on the x or bottom axis, and your dependent variable to be on your y-axis. Your independent variable or time, if time is your independent variable. So in the case of a rate over time, you would want your time in maybe hours or seconds or minutes or whatever it is, and then your growth rate, that would be GR for this case, your growth rate on the y-axis. And so you've got your data, you've got your graphs. Next you want to come up with a conclusion. And we will spend a little time learning about conclusions and writing them, but it's basically you expressing what happened. Your conclusion should include what happened with your hypothesis, whether your hypothesis was shown to be true or false. You always want that in your conclusion. So in this case, I thought that chalk would negatively affect the growth of the plants. And if that is true and it showed a negative growth for adding chalk, then I need to say that my hypothesis was shown to be correct. If it doesn't, then you need to say your hypothesis is shown to be incorrect, which is perfectly fine. We learn a lot from failure. That's not even really a failure if you show your hypothesis to be not true. That's actually, success. And so you'll write your conclusion. You'll include whether or not your hypothesis was shown to be correct or incorrect. The next step is very important in science. Without this step, we couldn't come to these truths, this knowledge. And so that's publishing your results. If you are doing science and research, once you come up with your results, if everything seemed to go all right with your experiment and your research, then you're going to publish it to a journal. And so you'll publish these results in what's called a peer-reviewed journal. And so other scientists will be able to look at your research, look at your experiment, repeat your experiment the same exact way, and pretty much try to prove you wrong. If they're able to prove you wrong, they'll publish their results and more scientists will come in and try as well. If they repeat your results over and over and over again, multiple scientists repeat your experiment and get the same results, then we're starting to build that amount of knowledge that soon it could become a theory or a truth in science. So a very important step to publish your results. When Watson and Crick first discovered and Rosalind Franklin, the woman who doesn't get much credit, first discovered the shape, the structure of DNA, they published their results first, I think, to Nature magazine, Journal of Nature. More scientists looked at their data, repeated their data, and said, yeah, we agree. That is the structure of DNA molecule. And so that's how we build knowledge and how we get to that final truth or that final amount of knowledge. And so lastly, the final thing for you to do now, the WSQ or the WISC is what we'll be doing for these videos, and so that stands for watch, which you just have done, so check. Down at the bottom you will see the summary questions, so you're going to summarize it by answering the short answer questions, and then there are a couple spots that you can have questions answered or asked of me. So I will see you in class tomorrow. Later.